Hi everyone, so how are you guys doing? So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT On this channel, every concept of physics, chemistry and maths is being taught to you completely in English. Now, this is a series that I host for class 11, and today we're going to talk about rigid body motion, and this is lecture number 5. Today mostly we'll introduce the terms of torque and angular momentum. Now, these concepts can be really tricky. So I would want you guys to pay close attention for today's lecture. Now, before I get started with the lecture, let me introduce myself one more time for those of you who don't know me. My name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for almost past 8 years, I've been teaching physics for the JEE Advanced and Mains exams. And all this teaching had been offline. And offline, I had been associated with some of the topmost institutes in the JEE field. Okay, now, I myself was All India rank 447 and All India rank 182 in the two stages of the IIT exam that I took. So you guys now take JEE Mains and JEE Advanced. So similarly, we used to have different two stages. And in the first stage, I secured an All India rank of 192 out of almost 5 lakh students back then. This is a long time back. And in the final exam, I secured an All India rank of 447, which used to be a subjective paper back then. Alright, now as a student, I also qualified the NTSC Stage 2 examination, and I was in the top 1% in the NSCP, which you guys know better as the first stage of the Physics Olympiad or the National Standard Examination of Physics. Now, I've already coached many students to top ranks in IIT JEE and in the offline setup, and I hope to continue doing that here online with you guys. Hi, Naman, how are you? So as I said, before this year, all my teaching had been offline and I was also forced to adapt and move online in this lockdown. So has been the case with a lot of you students. So this is how you can make the best of this tough period. You know, you can get yourselves the Unacademy subscription. This will help you get benefits like live classes where you get to interact with your educators. These classrooms also have live polls and leaderboards which keep them highly interactive and fun. Now you're also part of a test series which a huge number of students are taking. Then you have analysis sessions which help you realize where you're lagging behind and where and how you can improve on your performance. And of course, you have live doubt clearing sessions. So for all Unacademy Plus courses, every fourth session is a live doubt clearing session after every 3 teaching sessions. So that really helps you to take care of all your doubts. Your doubts never get piled up here. And on top of all these benefits, Unacademy is also providing you the opportunity to study from the best educators all across India, from the comfort and safety of your home. Now, this is a great chance, which trust me, is a very interesting development that earlier when I did my studies, so I did my studies from my hometown Lucknow. So there we did not used to have any big coachings, so we had to go for local teachers. Now you have the opportunity to study from all the best teachers from anywhere in India. Okay, so that I think gives you a great advantage. Now, these are the ongoing plus courses on the Unacademy Plus app for the JEE Mains and Advanced 2022 aspirants by the JEE English team. So there is one course by Abhinav sir for mathematics. There is a course on chemistry by Rahul sir. And I myself am taking an advanced course on mechanics, which is not only useful for 2022 aspirants, but also for 2021 aspirants. Okay. Now, there are another 4 courses which are meant for class 12 students or JEE 2021 aspirants. So there is one course that I'm taking which is an advanced course on electromagnetism. Then there are courses of maths, chemistry and physics again taken by Abhinav sir, Rahul sir and Murli sir. So how do you enroll in these courses and how do you make sure that you keep on studying even in this lockdown, and in fact not only study, get an edge over your competitors, get better education than them. So this is how you can do it. Follow these easy steps and install the Unacademy app. Once you have done that, you'll need to go to the plus section of your app, select your goal as IIT JEE and click on that get subscription button. Okay, so this is yet another thing which Unacademy has brought to you, and the Unacademy Combat. This is the most competitive and gamified IIT JEE battle. Okay, so you can compete live in this and it will be happening on the 8th of November, and you can enroll now using my code. All right, and you can win a lot of prizes. So make sure you're getting yourselves there. Alright. Those of you following us on the YouTube JEE English channel should also be connecting with us on the Telegram app using this link. And join this group so that you're not missing out on any of the lectures and sessions that are happening on the JEE English channel of YouTube. Now, first we'll resume our discussion of rigid body motion. So in the last class, we were talking about moment of inertias, how to calculate moment of inertias. So first we realized that moment of inertia for any continuously distributed mass can be calculated as integral of r squared dm. And for any discrete mass system, I would be summation of mi/ri square, right? Now, once we decide this, we also realize that I is always defined about an axis, right? And this r is supposed to be perpendicular distance from that axis. So theoretically, a body can have infinite moment of inertias. So how can I possibly calculate infinite moment of inertias? Do I have to calculate it every time? So it turns out, no, you have some help. Hello Rajesh, how are you? So it turns out if you know the moment of inertias of some common shapes about some important axes, then turns out you can calculate a lot of other moment of inertias about other axes using two very, very powerful tools, which are your perpendicular axis theorem and parallel axis theorem. So perpendicular axis theorem and parallel axis theorem are the tools that you want to use for calculating a lot of other moment of inertia. So I hope you remember these well. Okay, hello Shantaji, how are you? So why don't we get started with a tricky problem? So I wanted to take up this problem because this is one problem which most of the students in my experience have usually gotten this wrong. So in my experience, 95% people get this wrong. 95% students get this wrong. That is why I wanted to discuss this. Okay, so I would like you to give it a try and let's see if you can find the correct answer in one go. Okay, so what you've been told is, so first let me just tell you this and let's see if you are in the top 5% who get this right. Okay, so you have to find the moment of inertia of a uniform square lamina of mass small m about the axis shown. So the axis is like this. It is at an angle of 15 degrees from one of the edges of the square. It lies in the plane of the square itself. It's a uniform lamina. Okay, sizes of this square are a by a. So let's see, you guys give it a shot. Okay, so try this and try and give me an answer. In case you're watching the recorded session later, I would want you to try this while watching it recorded also. Give it a try and let's see if you can answer this correctly or not. Alright, so I'll give you, let's say 2-3 minutes for those of you who are watching it live to solve this. Let's see what you guys can do. So Naman, why don't you give it a try? So Naman, S. Pandey, Rajesh, Shantaji. So why don't you guys give it a try? Let's see if you can, if one of you or at least can answer this correctly. Okay guys, come on. Try this. By the way, you can also write trying in the chat just to let me know that you're trying to solve this so that I know who to wait for. Okay. All right. Let me know who all are trying. Because trust me, this is a very tricky problem. And there is a very, very common mistake that most of the people do. So one, this is a tricky problem. I think 60% usually are unable to figure out how to calculate this. Okay, out of the 40% that do, they make a very, very common mistake. That is why 95% people always get this wrong. So I wanted to bring you this problem so that I can show you that where are the mistakes that students commonly make so that you can avoid them next time. Okay. All right. So try this and try and give me your answer as soon as possible. So this is the axis of rotation. You want to rotate this square plate about this axis. Let's call that axis AA dash. So you have to find the IAA dash. All right, so Rajesh is trying. Rishabh, hi. How? What did you forget? What did you forget, Rishabh? So why don't you try this? Give it a try, and then we'll see. We'll see. Don't worry. Don't worry. Just try this. Okay. So what do you think would be the answer? Rishabh, why don't you give it a try? You are a 12th pass student, right? So you have to give these tricky problems a try, definitely. Oh, you forgot how to do this. Wow. Okay, that is why you need to keep revising. I hope you have you been watching my lectures regularly? See, you can't become slack even if you have studied all of this once. All right, so Rishabh is trying. Let's see if he can get this correctly. Okay. So trust me, guys. Even if you are in class first, and even if you've studied all these things first already, trust me. There are certain things that you wouldn't have thought of or you wouldn't have been told. So I'm discussing everything in a great detail. I'm showing you the proofs. I don't know how many of you already had seen the proofs of the parallel axis theorem and the perpendicular axis theorem, because mostly the proofs are never given to you. So I'm trying to give you a very very detailed picture so that you understand things better. Oh, last two you watched. Okay, okay, no problem. So 1.6 ma square. No, no, Rajesh, that is not correct. No, it is not 1.6 ma square. Okay, so 1.6 ma square, that would be 8 by 5, right? No, that is not the correct answer. It's okay. It's okay. Good that you tried though. So let's talk about Rishabh then. Let's wait if Rishabh can answer this correctly. Yeah, anybody else who's watching this can also give it a shot. See, when you try, you will realize where you're going wrong. If you don't try also, if you just see my solution, then trust me, you won't realize where you would have gone wrong. And next time you're doing this on your own, trust me, there is one common mistake that you'll make. Okay? So always better to try it right now. Make that mistake and then realize it, because that is when you will never forget about it. Hopefully. That is my idea. I want you to try this. And as I said, 95% students make that mistake. So it's a very common mistake. So I want you to first try. If you make that mistake, then I want you to realize where you went wrong, why you made that mistake. So if you don't understand where and why you're making mistakes, then how can you get rid of them, right? All right. So can we expect an answer from you, Rishabh? Let me know. Okay, so Rishabh says MA square by 4 cos 75. No, Rishabh, no. That is not correct. Unfortunately, that is not correct. Nope. Mhm, mhm, mhm. So did somebody tell you that you could resolve moment of inertias? It's not a vector quantity, right? I hope you realize it's not a vector quantity. So you can't resolve this. You can't try and find maybe the moment of inertia about this axis and take its cos component. No, that is not how it works. Okay. So let's see how you would have gone about it. So I'll tell you the way to do it. First of all, okay, no problem. Distance. So what do you mean by distance? Okay, so first of all, let's draw ourselves a diagram and let's see how we would have approached this. So here is a square. Okay, and let's draw ourselves the axis. Okay, so let's say that the axis would be something like this. Okay, so I can only make straight lines with this. Okay, I don't know if I can turn these. Okay, Hmm. Yeah, that seems to be a problem. Doesn't seem like I can turn it. Oh, I can. Wait. So I was able to turn this. Okay. Now let's see. Yes. So that is our axis of rotation. Okay, and now let's get back to. Okay, so first what we need to do is no Rishabh, even that is not correct. Even that is not correct. So first we need to draw up an axis parallel to that which would pass through the center. Okay, so I'll tell you. So let's say this is the center. I know if I know the moment of inertia of an axis passing through the center parallel to this, then I can definitely calculate the moment of inertia of this, right? So let's try and see if we can do that. So I don't know if yes. So this is an axis which we made parallel to this and passing through the center. Okay. So this is what we are going to do first. So first we draw an axis passing through the center. Okay. And yeah. So let's call that IC. So I had one AA dash and let's call this was AA dash. And let's call the axis parallel to this passing through the center CC dash. Okay. So first, can you tell me what is ICC dash? Can you tell me what is ICC dash? What will be the moment of inertia about the axis CC dash, which is parallel to A dash and passing through the center? Tell me. How much do you think is ICC dash going to be? Any ideas? Think about it. How can you solve this? Hmm. What? Half of what? Half of what? So first of all, let me tell you, this is going to be MA square by 12. 1 by 12 MA square. So how can I say that? How can I say that? No, not MA square by 2. It will be MA square by 12. Okay, so the first thing you need to realize is that what I'm going to do is that I am going to draw an axis which is perpendicular to this. Okay, how do I get this? Yes, perpendicular axis theorem. Exactly. So let's draw an axis which is perpendicular to this and also passes through the center. So passing through the center, perpendicular to this, I think yes, we have got this. So imagine this was another, and let's call this some y dash. Okay, so let's give it a different color. Yeah, this is an axis which is also passing through the center and perpendicular to this. Okay, yeah, I guess we have made it perpendicular. Yeah, that seems about correct. Okay, now what I'm going to tell you is that think about this, that look at the mass distribution with respect to the two axes. Okay, since square is a symmetric thing, square is a symmetric shape, so you realize this half and this half would be identical to this half and this half that you see. Okay, I hope you realize if I turn a square by 90, it appears exactly the same. Do you agree? If you turn a square by 90 degrees, it will appear exactly the same, right? Therefore, can I say the mass distribution about the axis AA dash, CC dash and BB dash would be exactly the same? Okay, so first of all, I can say due to the symmetry of the square, due to the symmetry of square, how am I able to say that? See, it's very simple, right? If you have a square like this and if you turn this by 90, you realize it is still a square. Exactly, everything remains exactly the same. So imagine if any axis was turned by 90 also, then the mass distribution would have been exactly the same, right? Now, due to the symmetry of square, I can say that the mass distribution about BB dash and CC dash would be exactly the same. Okay, about both these axes, BB dash and CC dash would be identical. So first you need to follow this logic. Okay. Now, as I had told you in the last class, if the mass distribution about an axis doesn't change, so the moment of inertia will also not change. Therefore, from this I can say that ICC dash equals IBB dash. Okay. Also from perpendicular axis. Also from perpendicular axis theorem. So if I made an axis perpendicular to the plane of the center, okay, perpendicular to the plane of the square and passing through center, also from perpendicular axis, I can say that ICC dash plus IBB dash would have been equal to IZZ dash. Okay, and let's draw ourselves that axis also. So let's see. We have an axis which is lying like this. Okay, this is the z-axis perpendicular to the plane of paper. Okay, and here it is going in the opposite direction. So z dash is that axis. So you realize, in fact, that this was a question which was asked in JEE long time back. JEE long time back. What they asked, I'll tell you quickly, is that they drew a lot of axes. So they drew axis like this, and they said the moment of inertia, let's say about this is I1, then about this is I2, then about some random axis passing through the center again is I3, and then you had another axis passing through the center which was I4. Okay, what you had to realize was that, again, using this logic, you realize if I draw any axis passing through the center which is in the plane of the square, the moment of inertia would exactly be the same for all such axes. Good evening, Aftab. How are you? Okay, so that is what you need to remember. For all such axes, whichever is passing through the center lying in the plane of the square, the moment of inertia would be exactly the same. Why? Think about this. Just like CC dash, if I had any other axis also, I would have drawn an axis perpendicular to that, and from, again, the symmetry of the square, the perpendicular axis would definitely have the same I because the mass distribution is identical. Now, since the sum of these two would have to be equal to IZZ dash, so all these would be IZZ dash by 2, right? So any such axis, the moment of inertia about any such axis would be IZZ dash over 2. Okay. So you realize in this case, the question that IIT had asked, all these I's would be same. I1 would be equal to I2, would be equal to I3, would be equal to I4. You draw any axis which passes through the center of the square, as long as it remains in the plane, all of them will have exactly the same moment of inertia. Okay, so let's use that. IZZ dash now I already know. IZZ dash was ma square by 6. I hope I had shown that in the last class. I don't know if you remember that. So since IZZ dash was ma square by 6, so I immediately get that ICC dash is 1 by 12 ma square. Now, so first, I think 60% of the students are not able to figure this out only. Okay, in my experience. I don't know if you could figure it out, so good for you, then you did well. Now, the second most common mistake that students do, I will tell you now about that. And be honest and let me know if you made this mistake yourself. So what people do is that when you have to calculate the perpendicular distance, so students often use this length, often use the length of the diagonal Okay, and let's say this is D. So this as your perpendicular distance between the two axes, and they use this in the formula of parallel axis theorem now. Okay, and they say that IA dash would be ICC dash plus D square, which is not correct. Which is not correct. Why is it not correct? Look at this angle. What is this angle going to be? So this angle is going to be 60 degrees. Right? This was 15. This obviously would be 45. So this entire angle, you realize, is 60 degrees. So this is not a line which is perpendicular to the axes. Okay. No. No. So this is 60. I want to calculate the perpendicular distance. So let's make a line which is perpendicular to both the axes. Okay, and then let's see. Let's see, Rishabh. Okay, so I will draw a line here like this. So this is the perpendicular. So this would be my D. This would be my D, and let's call that one D dash. Let's call this D dash. Okay. The same you did. Yes, I know. People use this as the distance between the two axes. That is not the distance. You have to take the shortest distance. Hello, Ajay Virat. How are you? Okay, so this was going to be your D. So how do you calculate this D now? Now that is another tricky part. So what you will notice is that this entire angle was 60 degrees, and this entire angle, that would be, let's just draw that angle. Okay, let's use some distinct color. This entire angle was 90. So what is this angle? This is going to be 30 degrees. Okay, and this was 90. Now you realize you can find D because you know D dash. D dash is half the diagonal, right? So once you know D dash, then you can calculate D. Okay, so now let's go about it. So since D dash is the length of the diagonal. Length of the diagonal is A root 2, okay, over 2. Agreed? This will be D dash. Yeah, 90 minus, yes. So why do you want to calculate this angle? This is not a, where are you getting a right angle triangle? So you have to first make a triangle, no? If you realize, then you are getting this. This is not a triangle. You have to form a triangle. This is a triangle. This is a right angle triangle. So that is what you need to do. So D dash I already know. D dash would be, the entire diagonal would be A root 2. So A root 2, half of A root 2. So this is A by root 2. Okay. Now from this triangle, so let's give these guys some names. So let's call this P. Let's call this O, and let's call this Q. Okay, in triangle PQO, what will you see? In triangle PQO, what you will see is that D dash cos of 30 equals D. Agreed? This is 90, so this will be hypotenuse. This is 30, so this will be the base. Yes. Now make sure that you never repeat this mistake again. So D would be equal to D dash cos of 30. So what is cos of 30? Root 3 by 2. So what you will have is, you will have A by 2 root 3 by 2. Agreed? This is what your D is. D is the perpendicular distance between the two axes. Correct? Now that I know this, I already knew ICC dash. Now I can use parallel axis theorem and find the answer. Okay. So let's see now, using parallel axis theorem. Using parallel axis theorem, I can say IA dash. So this is a very, very good question, a very tricky question. You should all try this, okay? So that would be 1 by 12 ma square plus md square, right? So that will be m times a square by 4 into 3 by 2. So you will realize here you have 8 and here you have 12. So what is the LCM? 24. Right, so you take 24 as the LCM. If you take 24 as the LCM, you have 2 here plus 8 you had here. So 3 into 3, you have 9 times ma square. So this is the correct answer. It is 11 by 24 ma square. That is your answer. Okay, so now remember this for the next time. Okay. All right. Another problem where I've seen students go wrong, make a very common mistake. So try this. You have to find the moment of inertia of a uniform semicircular disk about an axis perpendicular to the plane of the disk as shown. So it is perpendicular to the plane and it is passing through this point. This point is right above the center. Okay, this point is right above the center at a distance r again. And you have to find the moment of inertia about this axis. So again, let's call this AA dash. So find IA dash. What will be IAA dash? So give this also a try. And let's see if you make the mistake here also. Again, even if you're watching the recorded session, give it a try because trust me, that's a very common mistake again that students make. I want you to try it, realize if you make that mistake or not. And if you do, then remember that why you made that and you shouldn't be repeating that. Yes. That is what the common mistake is. No. No. You need to remember your COMs. See, that is why this chapter is taught after center of mass. You need to remember where the CMs lie. It is 4r by 3 pi. How can it be 3 pi by r? R has to be above. No, it has to have the dimensions of length. Yes, 4r by 3 pi is the answer. Absolutely. And for semicircular ring, what is it? What is it for semicircular ring? This is a disk, by the way. This is a uniform semicircular disk. So for disk, the moment of inertia, the center of mass lies at a distance of 4r over 3 pi. And how about for a ring? Where does it lie for a ring? So where is it for a ring, Rishabh? Tell me. रिंग का सीएम कहाँ होता है? So all you guys who are even watching this again the recorded way, yes 2r over pi. Again, all you guys should remember these. There is a reason you studied center of mass before studying rigid body motion. So okay, so why don't you solve this now? Try this now, Rishabh. Okay, and let's see if you can get this correct or not. So first, what do we need? So whenever I have a random axis, okay, I want to know the moment of inertia about an axis which is either perpendicular to this. So I could have done that. I could have used perpendicular axis theorem also here. Why? Because this is a 2D body. I could have also used parallel axis theorem. So do I know the moment of inertia about this axis? Maybe. How about this axis? I'll have to calculate. How about the axis parallel to this? Yes. So I think it's easier if I use parallel axis theorem. I can use perpendicular axis theorem also, by the way. I will tell you this. But I will need to calculate the moment of inertia about this axis first. And calculating it about this axis would require as much amount of work as it would have for getting this, okay, from here directly using parallel axis theorem. So that is how we are going to approach this. We are going to see an axis which is parallel to AA dash, Again, perpendicular to the plane of the ring, passing through the center of the full ring, and let's call this CC dash. Let's call this axis CC dash. Now you must remember one thing again, and that is the common mistake that people do. That what they do is we know CC dash, right? CC dash is mr square by 2. I hope you remember that. Why? As I told you in the last class, for any sector of a disk, the moment of inertia about an axis which is perpendicular to the plane of the disk, the moment of inertia remains mr square by 2 only. We discussed this problem which was asked in JEE Advanced, JEE Screening, right? So you already know this. You already know ICC dash. ICC dash you immediately know is mr square over 2. Now, the most common mistake that students do is that they apply parallel axis theorem directly between this axis and this axis. That you cannot do. Okay, that you cannot do. Why? Why? Because this is not the axis passing through the CM. For a semicircular disk, the CM does not lie here, right? It lies somewhere here at a distance of, so it lies somewhere here at a distance of 4r over 3 pi. Okay, so this would have been your ICM. This is what would have been your axis passing through the seam. So let's call this, okay, I should have called this O dash and that CC dash. Yeah, so that it makes more sense. Okay, so try this, and now I've given you the hint where you go wrong. So try and give me the answer very. Okay, so are you able to find it? So let's stick to the basic conventions. Let's call this O dash because this is passing through. Let's call this. We usually call this origin kind of thing. So O dash. What pi square? Okay. So IO dash. Let's just call this IO dash. Because I want to refer CC dash to the axis passing through the CM. Okay, that is why I'm doing this. Otherwise you can call any axis whatever you feel like. There is no hard and fast rule. I just like to use these symbols so that in my head I know whenever I say CC dash, it is an axis passing through the CM. Okay. So how do we solve this? Okay, term upon pi square upon MA. Okay, no, I don't think that is correct. The answer would be slightly more complicated. So what I will do now is I know that what all we know. So we know IOO dash we know is 1 by 2 mr square, right? And from here I could have calculated ICC dash also from parallel axis theorem. What I will do is I will write two equations, one for IO dash, and I can say that IO dash should have been equal to ICC dash plus m times 4 by 3 pi r whole square. Correct? Okay. And so let's call this equation number 1. And also IA dash. How much would that have been? That would have been ICC dash plus m of, and this particular distance would have been r minus 4r by 3 pi. Agreed? correct? Because this distance now, this total length was r, this was already 4r by 3 pi, this would be r minus 4r by 3 pi, correct? And that is the perpendicular distance between these two axes. Now all I need to do is subtract these two, okay? So equation 2 minus equation 1, let's just subtract these two equations and let's see what we get. Let's see what equation 2 minus equation 1 will give us. It will give us iaa dash minus io dash would be equal to. So when I subtract these, this and this will get cancelled. So I don't need to actually calculate ICC dash, right? What I will have is m times I will have here r minus 4r over 3 pi whole square minus 4r over 3 pi whole square. So this is a square minus b square. A square minus b square would be a minus b into a plus b, right? So I can say iaa dash would be equal to mr square by 2, which is io dash, plus m times, what is a plus b? A plus b would be r into a minus b. Okay, so that would be r minus 8r over 3 pi. Okay, so this is going to be an answer. Got it, Rishabh? A plus b into a minus b. I hope you guys know this now. A square minus b square equals a minus b into a plus b. So from this entire thing, I will take out mr square as common. If I take mr square as common, let's see what do we have. We would have had 1 here and half here, so that would have been 3 by 2. And minus, I would have had 8 over 3 pi. Okay, so this is going to be our answer. Did you get that? Okay, great. Great. So let's try another problem. Here what has been done is that a portion has been removed from a disk. This kind of question has been asked like 2-3 times at least. At least once in mains, and I think twice in at least once in advanced, and I think twice in mains. So let's try this. How do you go about this? So you've been told the moment of inertia of a uniform disk is to be found about this axis ixx. Okay, about the axis xx dash. So this is the axis. Okay, this disk has a circular hole in it. So this disk has a circular hole in it. So how do you calculate this? So see, if you will calculate this, then you can calculate the moment of inertia about this axis also, about this axis also. You can do all that. Okay. Again, there are many ways to find this. So I told you, whenever you are adding two objects, then the net moment of inertia can be found out by calculating the moment of inertias of each of the constituents about that given axis and adding them together. Similarly, here what you can do is either you can find the moment of inertia of this entire ring, entire disk, subtract the moment of inertia of this from it, or you can say that let's imagine this has a minus negative mass added to the disk, right? So you can assume that a complete disk was added with a negative mass disk, and that is how I got this. So this guy will have a positive moment of inertia. This guy would have had a negative moment of inertia only theoretically. Practically, nothing can have negative moment of inertia. Okay, I'm only doing this mathematically to answer. Okay, so Rishabh is fine. Great. Yes, so I can either use the negative mass concept, or I can simply just subtract the two. Okay, so try this. Great. Okay. So how about others? I want others also to try. And I think this is the last problem that I wanted to take up. And then yes, we'll quickly talk about the radius of gyration, and then we will start our discussion on torque and angular momentum, which is very important. And by the way, from next week, what we are doing is that we are going to have only two classes per week for class 11 students, and only two classes per week for class 12 students. So that makes it four classes, and then we will have three classes of quick review for revision for all 2021 aspirants. So we will start with kinematics. So the idea is that see, last year I took some one-shot lectures, right? So there were 3 hour one-shot lectures. So instead of having 3 hour one-shot lectures, what I've done is that this year we will divide every topic into two parts. Mostly we will try to divide every topic into two parts of 1.5 hour each. So in every 1.5 hour video, what we'll have is we will have 45 minutes of theory revision. I will only quickly go over the important parts of the theory, important bits of the theory, and then we will practice. For 45 minutes practice, 45 minutes theory. So this is going to be the idea. This is to help you quickly revise. So this is especially going to be helpful for class 12 students, who we teachers know that by the time you're finishing up with your class 12, you completely forget your class 11. So that is going to be a real help for you guys and for all droppers also. If you have completed all your syllabus, this will be a quick revision, okay, for all the key concepts and then practice. So make sure if you are planning to take your JEE in 2021 itself, then you are taking part in that series. That will definitely help you quickly revise these topics. This is consider this as your last minute push that we guys want to give you. So quick revision, quick practice, and we will also talk about some shortcuts towards problem solving. Okay, so then make sure you are attending those sessions. They will not only help you revise your theory, get some more practice, and I will tell you some shortcuts with which you can improve your speech. Okay. I'll try and give you shortcuts which are applicable in a wide variety of situations. Okay, mostly you will have shortcuts which apply in one or two kind of questions only. Okay, so in a very specific situation you can apply that. 255 by 126 mr squared. That could be the answer. I don't know. I don't remember the answer. Okay, let's see how we would have done that. So I can either say that this is a full disk. So let's draw ourselves a full disk. Okay, a full disk, and out of this you are removing a small disk. Okay, so let's draw this as a solid disk. First of all, let's stick to those colors only. Let's stick to bluish color. Let's fill this just to show that this is solid. Okay, so this is one solid disk. Okay, maybe let's make it light. And plus a small disk of negative mass. Okay, so let's show that by red. So small disk here of okay. Yeah, that does seem about right. Maybe we can just make it slightly smaller. Sorry. Yeah. So and then let's say that this is a negative mass disk. Okay, so let's fill this with some color. Okay. So this is the idea that I'm going to be breaking these two. I'm going to be breaking these two into two parts. So one I will say is a positive mass disk, and this has been added to a negative mass disk like this. Okay, so that is going to be the idea. So okay, let's just draw this as this. Let's have some separation between them. So what I'm trying to say is that I'm trying to think of this, that this has been achieved by taking a complete disk and then adding a disk with negative mass. So positive mass, and this one has a negative mass. Okay, let's see, we will confirm that. So what I can say is, so let's call this as ring 1, or not ring, actually it's a disk. So let's just give this a number. So let's call this a 1 and let's call this 2. So first of all, what I want to do is I want to calculate the moment of inertia of 1 and 2 individually about this axis. Okay, let's see. So I know for 1, for disk 1, okay, this is very easy. I know Ixx dash, let's write 1 with it so that we know we are talking about disk number 1. So that would have been M1 R square over 4, where M1 is the mass of this. Okay, where M1 is the mass of this. Agreed. Similarly, if M2 is the mass of this, then what would be the moment of inertia of that? Let's see. For disk 2 will be Ixx dash. Ixx dash 2 would have been M2, and the radius of the smaller disk is R by 2, right? Plus the perpendicular distance. The perpendicular distance would have been so about this axis I know the perpendicular distance would have been 3 by 2R plus M into 3 by 2R, M2 times 3R by 2 whole square. Agreed? And because the mass would have been negative, okay, so we will substitute the value of mass later. Now can I say that Ixx dash of the given body would be nothing but adding these two. So it would be Ixx dash for 1 plus Ixx dash of 2. Correct? Now all I need to do is substitute the values of M1 and M2. Now let's see that. How do I calculate that? So I knew for this the mass is M, okay, and what is the area? So I will find the mass per unit area. So that would be M over the total area would have been pi R square minus R by 2 whole square. Okay, so this would have been the sigma, right? So let's see how much we are getting this. So this would be M, and I would have had pi times, this is R square minus R square by 4. So 3R square times 4 here. Okay, correct? Now the area of the full disk, is pi R square. So M1 would be 4M over 3 pi R square into pi R square. Okay, so this is, I got M1, which is 4M by 3. Okay, how about M2? Okay, no problem. Okay, so this was M1. So M1 I calculated. Similarly, M2 also I can calculate. What will be M2? M2 would have the same negative sigma. Okay, M2 would have been minus 4M by 3 pi R square into the area of the second disk, which would be pi r by 2 whole square. So pi r square by 4. So this goes, this and this go. So I have minus m by 3. This is my m2. Do you guys follow this? How I got these? Okay. So once I have this, all I need to do is substitute these here. So let's see what our answer comes out to be. So this is 4 m by 3 into r square over 4 minus, I can take out mr square common from here. So mi square common, if we take, then I have minus m by 3 into r square. And then let's see what I have left here. What? Yes, tell me, Rishabh. So in fact, so I will have, in fact, 1 by 4 and 1 by 4, so that is 1 by 16. Plus, I have taken r square common, so I have 9 by 4. And this is ours in advance. So I know this is slightly lengthy also, but what to do? If advanced can ask these problems, we have to solve these. Even if you find this boring. And this was asked in objective one only, not a subjective paper, okay, by the way. So minus mr square by 3, and then you have 16 LCM you will take, and then you will have a 1 here. Okay, what did I do? Did I do something wrong here? So this is r by 2, so m by 3, r by 2 square over 16 plus m, which is m by 3 again, d square, which is fine. Okay, so 16, if I take the LCM as 16, then I have 9 into 36, 9 into 4, so that's 36 plus 1, 37. Okay, so that is weird. Am I getting a negative answer? No. What did I do? Let's just check our calculations once. Yeah, that is the sad part. So where did we go wrong? Oh, of course, this was said 2r. Yeah, it was 2r. It was 2r. So this would have been 4. Yeah, rest everything is correct. For the first one, I did not realize that this had a radius of 2r. So here also everything will change. This will be into 4. So this would have been 16. So that is a problem with such longish problems, that you may miss out on one thing. Thankfully, the negative answer told us that we have done something wrong. We have missed out on something. So sigma also, here also you would have had, okay. Yes, I know. Here also I'll have to redo everything. Damn. So let's just quickly redo it. Thank God I noticed. So let's just very quickly redo this. But I hope you get the idea how to solve this. Okay, so sigma would have been here also. I would have had to redo this down. Okay. It's just that by default you take the radius of the disk as r only. So that is what I did there. Subconsciously, I just put the radius as r while it was supposed to be 2r. And that is how you're getting a negative answer. Yeah. So, okay, this was correct. So this would have been m1r square. And this is also correct because I took this was r by 2 only, and this distance I took correctly. So this would have been m over the area, that would have been times 2r square, which is 4r square, minus r by 2 whole square. So it would have been like this. So yeah, a lot of calculation here. What to do though? So this becomes 4m over pi, and this becomes 16 minus 115. So this is your sigma. Correct. Now m1 would become 4m by 15 pi r square into 4r square, 4 pi r square. So this goes, and you have 16 by 15m. And for M2 again you have minus times 4m by 15 pi r square into pi r by 2 whole square. So that is this. So yes, this goes. So you have minus m by 15. Now you can substitute these and calculate. So ixx dash I know would be ixx dash 1 plus ixx dash 2. So whenever you're solving, you should be aware of these. So I always do this. I logically cross-check my answers if my answer makes sense or not. So obviously this could not have been negative. So there I can catch my mistakes. So trust me, even I make mistakes. So just like you guys, so nobody's perfect, alright. But what you can always do is always try and cross-check your calculations with logical arguments. So does your answer logically make sense? If it does not logically make sense, then of course you have done something wrong. Okay, minus mr square by 4 I will take common from here. If I take mr square by 4 common, so I have m for this into r square by 4 I have taken common. So inside I'll be left with 1 by 4 here, and plus I will have 9 here. Okay, and now we can take mr square by 15 common from the entire thing. So if I take mr square by 15 out of the entire thing, then what do I have left? I have 16 minus this is 1 by 4, and that will be 13 plus 1, 36 plus 1, 37 over 16. Now you can solve this. Okay, this would have given your answer. A very, very big answer, but you'd have gotten. Alright, so let's just move ahead. So make sure you are also very, very careful in doing your calculations. Okay, and taking up your values. These are common mistakes that people do. Oh, me included. Anyhow, so let's talk about radius of gyration next. So what is radius of gyration? Radius of gyration of a body about any axis of rotation is assumed distance from the axis of rotation at which all the mass of the body can be assumed to be concentrated in order to have the same moment of inertia. So assume if I were to replace a body by a single mass having the same mass as the entire body, at what distance it should have been to have produced the same moment of inertia about that axis. Okay, so that is the idea. The radius of gyration is the radius in which a small point mass of the same mass would have been rotating in order to have the same moment of inertia as this. So the idea is sometimes okay, great. So 219, are you sure? 219, 16 into 16, how much is that? 256. Yeah, you could be right. Yes. So that would be the answer. Yes, you are right. 219 over 240. That seems like correct. Okay. All right. Great. Okay. So again, coming back here. as I was saying, so the idea of radius of gyration is either just to tell you. So what we do is for randomly shaped bodies, we just tell in the questions they will just tell you that radius of gyration is some k. So if k is given, you can immediately find I would have been m times k square. If you know the mass of an object, if you know the radius of gyration, then you can immediately find the moment of inertia. Now you realize that radius of gyration would also be defined at about some axis only. So because moment of inertia is always defined about an axis, so radius of gyration is also defined an axis. So one body can have many radius of gyrations depending on which axis we are talking about. So please remember this. Okay. Now, so you have this relation, and if you have this and this, then you can find this. Or the other way around, if you knew I and m, then you could have found k also. So let's quickly try one problem, a couple of problems, and find the radius of gyration here. So in the first question, you've been told find the radius of gyration of a uniform circular disk of mass m and radius capital R about a line passing through a point at a distance r by 2 from its center perpendicular to it. Okay, so I hope you got the situation. So this is what the situation is like. Okay, so there is a disk. There is a disk, uniform disk, mass m, radius r. So this is an axis passing through its center, and you have to find the radius of gyration about an axis which is at a distance of r by 2 from the center and perpendicular to it. So this is the axis about which you want to find the radius of gyration. Okay, so try this. This is RAA dash, about which I want to find the radius of gyration. It is at distance r by 2 from the center. Root 3r by 2. Let's see if that is correct. Okay. So let's see. So I already know what is ICC dash. How much is ICC dash? ICC dash for a uniform disk we know is mr square by 2. Now from parallel axis theorem, we will realize that IAA dash would have been mr square by 2 plus m times r by 2 whole square. Okay, so that would have been, yes, 3 by 4. Right. So yes, root 3r by 2 would be the correct answer. If k is radius of gyration, then you know if k is the radius of gyration, then you know mk square equals 3 by 4 mr square. Okay, and from here you will easily get that k is root 3r by 2. So very well done, Rishabh. That is the correct answer. Yes, well done. 3r by 2. Okay, how about this? So try this. Here is another question for you. Okay, so practice problem. You have a uniform rod of mass m and length l, which is making an angle theta with the vertical touching one end to it. Okay, and you have to find the radius of gyration of the rod about the line. Okay, about this line or about this axis. So let's call this one A dash now. So find me the radius of gyration about A dash. Okay, Rishabh, try this. Okay, give it a try. So quickly try this. Okay, so hi Rashil. So Rashil, I am currently in Delhi. Originally born and brought up in UP Lucknow. Okay, and I have been settled in Delhi for almost past 17 years, 17, 18 years. I did my studies from here, and after that, I've been settled here only. Okay, so Rishabh says ml square by 3 sine square theta. So what has been asked, Rishabh? You have been asked the radius of gyration. So not the moment of inertia, find the radius of gyration. So let's see. Okay, let's see. What we can do is that if I consider an element which is at a distance x and has a thickness dx. So first I need to find the moment of inertia. So speak English, please. So I am speaking English. Am I not? Okay. So this will be the r perpendicular, right? So what is the r perpendicular of for this element? For this small element, the r perpendicular would have been r sine theta, right? X sine theta. So for dm, for r small mass dm, r perpendicular would have been equal to x sine theta. Hello to who? Almudena. What is that? What is that? I am speaking in English, by the way. I don't know what kind of English are you expecting? And what will be dm? Dm would have been lambda times dx. So I know moment of inertia, I a dash would have been integral of dm r perpendicular square, right? And that x would have gone from 0 to L. So let's quickly do this. So this is r square sine square theta lambda dx. Okay, and x going from 0 to L. So yes, this would be lambda L cube by 3, lambda L cube by 3 times sine square theta. Okay, and lambda L obviously is m, right? So lambda equals m by L, or mass per unit length. So again, lambda into L can be written as m. So I know I a dash would be equal to ml square by 3 sine square theta. Okay, that is the answer that you are given, Rishabh, right? So yes, this is correct, but you had been asked to find the radius of gyration. So you would equate this to mk square, and which will give you k as L sine theta over root 3. Okay, so that is going to be your answer. L sine theta over root 3. Okay, I hope you followed this. Okay, got it, Rishabh? All right, so that is all the discussion that I wanted to have about moment of inertia, radius of gyration, and everything. Okay, now let's get started with the teacher. Why I can't understand physics, but I can understand why. So just focus on physics and you will understand it. Don't worry. Just focus. Try and focus on all the reasons, all the logics, why something is being said as it is being said. Okay, so try and follow the reasoning. If you follow the reasoning, you will understand physics. Don't worry. Physics is a very logical subject. Everything has a reason. Everything has a logic. Okay, there is nothing happening out of the blue. So if you start following the logic, if you start following the reasoning, don't worry, you will understand physics also. Okay. So next we will talk about torque and angular momentum. So till now we studied about kinematics of pure rotation. We also realized that the kinetic energy of pure rotation would require the calculation of moment of inertia. So we calculated that, and we realized that moment of inertia was nothing but the measure of inertia of rotation, right? So now, before we move, now we will move to the dynamics part of pure rotation. So we understand how the motion is happening. Now we want to understand why the motion is happening. So what we realize is we will introduce two new terms. One is torque and another is angular momentum. Okay, so let's talk about torque first. So what is torque? Okay, so torque is a physical quantity responsible for change in state of rotation of a body. So just like force was something which is responsible for producing a change in state of translation or state of motion, right? This is what will change the state of rotation. Okay, this is that physical quantity. Now, rotation has the same role in rotational motion as force has in translation motion. Okay, it plays the same role uh, in rotational motion as mass in translation. Okay, so this is not, this should not have been there. Okay, so let's cut this out. So it is very similar. It is very similar to, it is very similar to, very similar to your force. Okay, we have already talked about this. Now, torque is a vector quantity and it can be defined in two ways. First of all, it is either defined about a point or about a line. So why are we doing this? Why are we doing this? Torque is a vector quantity. SI unit would be Newton meter. And this is how we define the torque, by the way. So first we will talk about torque about a point. So if force F is acting on a rigid body at a point P, then the torque tau on acting on the body about the point O due to this force is defined as tau O equals R cross F. Okay, so this is how you define the torque of the force F about O. Okay, so where R is the position vector of the point of application of force. Please remember that R is the position vector of the point of application of F with respect to O. So whatever point you are calculating the torque about, you have to take R as a vector originating from that point going up to the point of application of the force for which the torque is being calculated. Now, what exactly do you think physically torque means? Okay, so let's talk about this. Let me add a page. So what essentially it's telling you is it is the measure of effectiveness. Okay, okay. So torque is essentially a measure of effectiveness of a force to produce the change in rotational state. Okay, torque is a measure of, not every force can produce a change in rotational state of any body. I will show you examples. So we can say that torque is a measure of effectiveness of a force, effectiveness of a force in producing the change in rotational motion of an object or a body. Okay. So think about this. So let's take up some examples. Let's take up some examples. Okay. Oh, so what Suraj says outside the universe? What outside the universe? Hello Suraj. How are you? Okay, so let's take up an example, and what I'm trying to show, what I'm trying to say here is that let's see. Imagine if you had a rod like this. So, okay, so let's imagine a rod, maybe a smaller rod. Yeah, this seems about perfect. So let's imagine such a rod. Okay, let's make the color slightly light. Okay, so let's imagine that this was a rod and it was fixed at one end. Okay, so let's imagine that this was a rod which is fixed at one end. Now what I want to know is, if I applied many forces on this, then you will realize that not every force will be able to produce a change in its rotational state. What I mean by that is, let me just show you. So let's say this is the rod and this is hinged at one end. Okay, so let's assume that this is hinged at one end, which means it is fixed at one end. So I hope everybody knows what hinges are. So hinge means this contact. Hinge is a contact which can allow rotation of this about the contact point, but it cannot allow it to move away. So this point itself is fixed. Now things can rotate about this. Okay. Now imagine different forces acting on this. So let's imagine if you have a force acting on it like this. Will it be able to rotate the rod? Let's talk about F1. Will F1 be able to rotate the rod? No, it won't be. However, if you applied a force like this, F2, then F2 turns out will be able to rotate this rod. Similarly, this kind of force would have rotated this the other way. Okay, you could have applied this force here also. Let's call this F4, and you could have applied a force here also. Let's call it F5. Now just compare all these forces. You will realize that this rod can rotate about this point. Let's call that O, the point at about which it can rotate. Okay, so imagine this is the point about which the rod can rotate. Now F5, you will realize, will never be able to rotate this rod. If you apply a force here, then you will never see any rotation of the rod, right? Similarly, F4 can produce rotation. F3 could have produced rotation. F2 could have produced rotation. This also could not have produced rotation. This could not have produced rotation. Okay, so this is what I mean, that not every force can actually cause a rotation. If you had any force like this, so let's say F6 is acting like this, then also you could have had rotation. So you realize that whenever you have such a situation, whenever you have any force acting, oh, thank God. So whenever you have any force acting like this, so it will have two components. So the component which is parallel to this position vector will never be able to rotate it, and this component will be able to rotate it. Okay. So Suraj says, sir, where was our universe expanding just after Big Bang? Where was our universe expanding? Where there no was there another space outside singularity? Give me an answer at the end of the lecture. So okay, you know what? I will give you an answer right now only. We believe that space is also created in the Big Bang. Okay, there was no ideas of space and time. We believe that space also got created in the Big Bang, and space is also expanding now. That is the idea that we have. Okay, we don't know much of what would have been there before Big Bang. Okay, we really have no idea. We believe that the space as we know it now, and the space and time as we know it now, both of them got created in the Big Bang only. Okay, that is the best that I know about this, Suraj. That is the best answer that I can give you. Otherwise you'll have to ask some other expert who knows more than me. So we realize that whenever you try to open a door, also, so if you're trying to open a door, you realize all the hinges, all the handles are towards the end, right? For the doors, you would have noticed that every door has the handle near the end only, so which you can push and pull to open that door, right? So every door has a handle here towards the end. They don't have handles on this side. Why? Because of the idea of torque. Because you can apply a smaller force and rotate this door open or shut. You would have had to apply a huge amount of force had the handles been given here. So that is what we will realize. We will experimentally realize that one, this component of the force can only provide rotation, and similarly, the farther this component, the more effective it will be in producing the rotation. Okay, and that is why we are defining torque like this. Okay, that is why we are defining torque like this. Torque about any point. So the capability of this F in order to produce a torque about this point or rotate this object about this point would depend on the cross product of R and F. Okay, Suraj, great. Go ahead. All right, now I hope you understand what exactly torque is, why we are defining like this. Because we saw experimentally that the effectiveness of a rotation of a force or effectiveness of a force in order to produce rotation will depend on both these things. It will depend on this component, which is what you will get if you calculate the cross product, and it will also depend on the distance of that component. The farther it is, the easier it would be for a one to produce a rotation, for any F to produce rotation. Okay, so this is rotation about a point. Now you also have rotation about a line. Okay, so rotation about a line, what does that mean? Okay, so rotation about a line, when you have to define, so what you say is it is the effectiveness of this force to produce rotation about this axis. So if this was the axis of rotation, then how much rotation can it produce? So you realize then you will have to take a component perpendicular to this only. Okay, so you realize this is R perpendicular. You have, when you consider R cannot be this. R would be R perpendicular from the axis. Okay, and that is how you determine this. In other words, you can also say R cross F. You see R cross F. So let's imagine this was the axis and this was the point where the force was acting, and let's say the force was acting somewhere here. So what would have been the direction of R cross F? R cross F could have been here. So this entire torque will have tried to produce a rotation like this. So this cannot do that because the axis is fixed. Okay, it can only rotate about this, like this. So what you will do is you will divide this torque into two components. So one this component, one this component. Now this component will not be able to produce any rotation about this axis. Only this component of the torque would produce rotation about this axis. So this component is ignored, and this component of torque which lies parallel to the axis of rotation is called the torque about a line. Okay, I hope you get that. So first find the torque about any point on the line and then take the component parallel to the line. Okay. So if a force is acting on a rigid body at a point P, the torque on the body about okay, this is right. So this is also mod of O would be R perpendicular. So what you can say is it is the component of tau about any point about in this direction. Okay. So torque about a line is component of tau about any point parallel to the axis. Okay, this is how you say torque about a line. Now the point is, why are we defining everything about a line or a point? What does that even mean? So that is one discussion that I want to have in the next class. Okay, so I think we have already run out of time. So trust me, this definition of torque is in itself very complicated thing. So I will start this discussion again in the next class. We will talk about this again. That what do I mean when I'm saying that rotation about a point? So rotation, say if this is fixed about this, then you realize it will rotate about this only. But in my definition, you realize in my definition, if my O lies here, imagine if I wanted to calculate the torque of this about a point O dash, which lies here only in this line, O dash. So what will be the tau of F2 about O dash? What will be the torque of F2 about O dash? It will be 0. Why? Because the radius vector of point of application of force is parallel to the force itself. What does that even mean? That about this point, this F2 cannot produce any rotation. Is it? What does that mean? What does that mean? We will talk about that in the next class. Okay. Trust me, this is a lot to process. So take some time, think about things, listen to what I have to say, and if you really want to understand, if you don't want to understand, then you can just stick to your formulae. Just memorize your formulae and just know what to use where. Yes, it will be 0. So why? Why am I saying? Why am I saying? See, the rod is not going to rotate about this point in any case. Rod is not going to rotate about this point in any case. Rod would have rotated about this point. So it is 0 about O dash. And if I took any random point elsewhere, so suppose if I took a point O double dash, then I would have had a non-zero torque, right? So it is producing a rotation about this. It is not producing a rotation about this. What? Yes, A dash. Tell me. How many days rotation will take? I don't know. I don't know. At least 14 days, or maybe I don't know. We've just had, this is the fifth lecture, right? This is the fifth lecture. So another 3 weeks at least. Yeah, 3 weeks, because in every week now from next week onward you will only have 2 classes. You will only have 2 classes. So that means I would want to discuss this for another at least let's say 6 to 8 lectures. Okay. So probably six lectures would mean at least 3 weeks. Okay, F parallel to O dash. So we will talk about this in the next class. That what do we mean? That the torque of this point, this force about this point is nothing, about this point it is something. Okay. Probably. So on banking road, why we got friction on both sides, right and left. So that is because you can have two tendencies of slipping. Okay, A dash. You can have 2 kinds of tendencies of slipping. So I'll quickly answer you. So, okay, before I answer A dash, let me just remind you guys, if you haven't gotten your subscriptions of the Unacademy Plus, then this is how you can do it. Go to the plus section of your app, select your goal as IIT and click on get subscription. Okay. And when you're getting to the payment page, this is the code that you can use, okay, to get a 10% off on all your fees. Okay, these are the ongoing, sorry, excuse me. These are the ongoing courses on the Plus by the JEE English team. Okay, so 3 courses for 2022 aspirants, 4 courses for 2021 aspirants. Okay, so maybe yeah, here I have some space. So let me tell you, A dash, what happens is that in case there is banking, so if you assume there was no friction, let's assume there was no friction. Okay, what would have happened then? If there was no friction, if you draw the FBD of this car sort of thing, and this is trying to take a turn, right? And let's say this is the center. So let's try and draw the FBD. Okay. So what are the various forces that are acting on this? So one you will have N. Okay, one you will have N. Another you would have had mg. Okay. Now what I can do is I can also, if I go to the reference frame of this, so I'm making this FBD in the reference frame of this car only. Okay, so I will have yet another force which I'm applying as the pseudo force. Let's say I apply a pseudo force of mv square by r. Okay. Now you will realize that what happens is, if you resolve all these forces, if there was no friction, so let's assume if there was no friction, let's resolve these forces. So I will have 2 components of this, one along this, correct? And I will have 2 components of this, one along this, one along this. Now for lower speeds, you realize for lower speed, so it can happen that mg sine theta is greater than mv square by r. Do you agree? So you have one force of mg sine theta, which is trying to pull it down the incline, and then you will have a force of mv square by r cos theta, which is trying to pull it up the incline. Okay. So if you're taking the turn very slowly, imagine if this is smaller and if mg sine theta is greater, then what will happen? This block will try to slip downwards. So if it tries to slip downwards, it will have friction acting upwards. Got it? If it tries to slip downwards, so let's just write that down quickly. You will have to have friction acting upwards in that case. Okay. So if mg sine theta, is greater than mv square by r cos theta, tendency to slip down and friction will be up, right? Now, if you increase the speed while taking the turn, no, we are only dividing the components along this and perpendicular to this. So perpendicular to this, mg and the other component of mv square by r would be balancing this. No, n would be perpendicular to this. So n cannot cause the slipping. The only two forces which can cause the slipping over this incline are these two, right? So that is why I'm only considering these. So tendency to slip down and friction would be up. Friction up the incline. And if you increase your speed, you can increase your speed to an extent where mv square by r cos theta would become greater than mg sin theta. Now you realize the pseudo force is trying to push it up the incline and mg cannot stop it. So now the tendency of slipping would be upward and friction will act downward. Got it? Did you understand what is happening? In this case, you will see tendency of slipping is up the incline and therefore friction will act down the incline. So it depends on where it's going to slip. If it would have wanted to slip upwards, then friction would act down. If it wanted to slip downwards, friction would act up. Friction would want to avoid the slipping, right? Tendency of slipping up, friction acts down the incline. Correct? So you have one force which is trying to move the car in one direction. You have another force which is trying to move the car in the opposite direction. So if, depending on whichever is higher, there can be motion tendencies or slipping tendencies in both the directions. Okay, so that is the explanation. Okay. All right. Now, if you like today's video, then don't forget to press the like button and share it with all your friends. So as I keep saying, so those of you who can't afford the Unacademy subscription are always welcome to receive free quality education on this channel. So make sure that you're sharing it with all your friends so that everybody can benefit from this. Don't forget to press the bell icon, and the PDF of all the slides you used in today's lecture would be available for download very soon. Don't forget to join us on the Telegram app using this link. That is my time for today. Before I leave you, let me remind you one final time. But why friction are on both sides? So it's not on both sides simultaneously. A dash. It does not act on both sides simultaneously. It will act one time in one side only. Okay. Now this is my code that you can use to get 10% off. So okay, let me just tell you this. If this was kept here, if one person was trying to push it from here, one person was trying to push it from here. So what will happen if this guy is applying a higher force? Okay, imagine if I am trying to push it from here and somebody else is trying to push it the other way. So what will happen? Okay, let's take up a book or something. Yeah. So imagine from both the sides, two people are trying to push it. If this guy is applying a higher force, it wants to slip on that side. If it wants to slip on that side, friction will act on this side. If this guy is applying a higher push, so this guy wants to slip on this side. If it wants to go on this side, then friction will act on this side. That is what is happening. Okay, at one time, the friction will act only in one direction, no? Not in both. Okay, so that is it from my side. I'll see you next on Monday. Till then, you guys take care, keep studying hard. Okay, bye-bye.